In our previous chapter, we primarily focused on loading and working with JSON data files using external table from external stages and understood how to query JSON data even without loading it into a Snowflake table. We also discussed the performance of JSON queries and limitation of internal stages with external table with respect to JSON data files. The first three chapters on this playlist had already covered many other key concepts like loading JSON via insert statements, variant data type, AWS S3 integration for JSON files, loading data from SnowSQL CLI, and many more. This chapter will deep dive on querying and processing the different kind of JSON data files and understand the different approaches which can be applied using Snowflake inbuilt SQL functions and operators. We are not going to use flatten function in this video, and for that you have to go to the future chapters. I would request you to understand these JSON SQL functions and operators and their core purpose and how and when to apply them as per different JSON data processing need. In this chapter 5, we will cover what is the meaning of querying a JSON file versus valid JSON file. What does it mean by query a JSON versus processing a JSON versus working with the JSON files? Different type of JSON data files and their classifications so we can design an approach before they are being processed and queried. How to use parse JSON, check JSON, JSON extract path text and process dynamic and complex JSON files without using flatten functions. During the hands-on exercise, we will also go and deep dive into query profile screens and understand the associated steps when JSON data files are being processed. This chapter is completely hands-on chapter, so stay tuned until the end. Welcome back to my channel Data Engineering Simplified and to this Handling JSON Data in Snowflake playlist for true data professionals like you. This is a complete playlist to cover JSON handling in Snowflake. Link for all the chapters can be found in the description section below or click above in the information icon. So let's start with chapter 5, working and querying different type of JSON data using Snowflake inbuilt SQL functions and different kind of operators. Let's understand JSON data file classifications. At very high level, we can look into JSON data files into 4 different categories. There are JSON files which are just key value pairs and does not involve any processing complexity to extract individual elements. They can be classified as simple JSON structure. Second category of JSON data file that comprises arrays and objects, one or more nested element inside an element. Such JSON file can be classified as a complex JSON structure. The third category is sparse JSON, where we may have many empty fields or null values, and it can also have arrays or objects inside an objects. You may also find JSON data files that has inconsistent structure and formatting. Such kind of JSON file can be classified as inconsistent JSON structure, and we will see the examples. It is important for you to classify the JSON data files before you process them. Higher the complexity or inconsistency level increases the processing complexity as well as the compute cost. Since Snowflake is pay-as-you-go model, you as a data engineer or data professional has a lot more flexibility and control to optimize the compute cost, only if you know how to do that. So let's see some example of these 4 types of JSON structure and then start querying using Snowsite web interface. This is an example of simple JSON data file. We have only one root element and all the employee attributes are there inside this single root element. Nothing complex, and using colon operators in Snowflake, you can access all the element if this JSON is stored as a variant data type. The next example is a bit complex JSON structure. The second level element of the employee object has arrays and objects, and that makes this kind of JSON structure bit complex to process. It can go any level down to increase the complexity, and subsequently it increases the compute cost. This is an example of sparse JSON. It has empty and null values for many elements. If you pay attention, the employee ID 1 object does not have degree and it is null. On the other hand, the employee ID 2 has no education detail information available, and that's why this kind of JSON is called sparse JSON. However, it is a completely valid JSON data file. Our fourth example is an example of inconsistent JSON. On surface, they may look like a sparse JSON, but they are not. In inconsistent JSON, some element will appear or may not appear at all for the next instance of the same object. In this example, employee ID 2 has a phone element, but other two employees don't have any phone element at all. On the other hand, the third employee has address element as an object, but first two employees don't have address element at all, and that makes this kind of JSON classified as an inconsistent JSON structure. This is the JSON data file from Twitter API, and you can pause and review it. It has deep nested elements, objects inside objects, includes arrays as sub-element, and also sparse, but certainly not an inconsistent JSON. Let's try to decode some of the common terminologies used frequently with respect to JSON processing before we proceed for our hands-on exercise. When we say query JSON, we are referring to the process of searching and extracting a specific data element from JSON data file using a query language, and in this case, it is SQL or Snowflake supported SQL. The query is used to navigate through the structure of a valid JSON object and select the specific data or a data element that is needed. I have observed the term query JSON can also be interchangeably referred as a processing JSON or a working with JSON. Before we start navigating any JSON object or a JSON data file, it has to be a valid JSON structure. Else querying or processing the JSON file will not work. So let's jump into our Snowsite web interface and start using colon, dot and bracket notation query the different type of JSON files what we have covered so far in the theory. Here I am in my Snowsite web interface. Let's switch the context quickly. I'm going to create a table called employee table, and this table has one field called JSON data of type variant. So my employee JSON01 is created successfully. Now let's insert a sample data into this employee JSON01 table. This is how my JSON file looks like. Let's copy this JSON into my JSON visualizer and see how does it look like. So this is a valid JSON. So the first level of element is employee, followed by employee's attributes like ID, name, and so on. And this is how this visualization looks like. Employee root element has an object, and this object contains all other employee attribute. If you do not understand why I am following this structure, I would request you to watch my first episode in this playlist. So if we have to insert a JSON object, we have to use the parse JSON function in Snowflake, and then we can insert that record into our table. So let me insert this employee JSON data into employee JSON01 table. So the data got inserted successfully. Now let's execute the select statement. This is how my JSON data looks like, and here it is representing that it is a variant data type. Now I can use this colon notation where JSON data is the name of the column and employee is my first root element within that JSON structure. So this is my root element. So if I have to access the root element employee, then I have to follow this structure where I will keep the name of the column followed by colon followed by the root element name. So let's run this statement. Now let me click on this. I can see my employee root element is not appearing, but entire structure inside the root element has come as a result. Good. Now if I have to access the level 2 element, which is nothing but an ID, I can use the dot notation and access the ID element from the employee object. Now it is giving me 1, okay, which is good. I can use the alias and change the name of the column. So now employee ID 1 looks good. So if I have to access all the sub element under the employee root element, then I have to use the colon notation to access the root element and followed by dot notation to access the sub element, and this is how it looks like. So this is my id, my name. My name needs to be typecasted to varchar because string is not automatically typecasted. Designation, salary. If you look into this structure, id is a number, name, designation, departments are string. It has to be typecasted to a varchar or a string or a text. Salary will be typecasted automatically. Joining date needs to be casted to date. So is manager is a false and is contractor is a null. So I would also cast them to be on the safer side. This is how I can access all the element from the JSON object and convert into a tabular structure. Let me execute this query. Now I can see employee ID, employee name, designation, salary, date of joining, is manager and is contractor. Now if you pay attention to line number 45 where I have used toDate function to cast it into a specific date format. If I don't use it, if I use date of joining using double colon operator to cast it, let's see what happens. It cannot recognize 1st of January 2020 because Snowflake's default date format structure is YYYYMMDD. So now we know if we have to extract an element and typecast it, we have to understand the Snowflake's default behavior and how Snowflake implicitly cast the object from the JSON file structure, and accordingly we can use different function to cast them into appropriate data type. So what happens if you replace all your dot with colon notation? Will it still work? Let's first try it and then understand. So this is a select statement where all the dot notations are replaced by colon notation. So this is the same query. Only thing which I have changed it here, the second level element is being accessed through the colon notation instead of dot notation. And let's try this out. This brought exactly the same result. So whether you follow dot notation or a colon notation for all other child element, the Snowflake still works. So you can either use colon notation or a dot notation. However, dot notation is more recommended because it helps you to identify whether you are accessing a root element or you are accessing a child element within the root element and so on. In chapter 1, we have only covered the colon and dot operator. Snowflake also has another notation called bracket notation, and let's understand how the bracket notation works. So this is the structure of the bracket notation. Here, if you look into this select statement, this is the name of the column, which is a variant type column, followed by the root element. If you don't want to use the colon structure, you can also use the bracket notation. Text inside the bracket has to be in a single quote. Let's run this SQL statement and see how does it work. Here I got exactly the same result the way I got it from this particular SQL statement where I have used colon notation. If you feel you or your team members like to use the bracket notation and it is more expressive, you can always use bracket notation. One thing to remember, whether you use bracket notation or whether you use colon notation, so the JSON element text is a case sensitive, and if you use uppercase or a mixed case, you would end up getting a null value. Let's try this SQL statement. The first column fetch the root element. However, the second column failed to fetch the root element because the root element text is employee, not the employee with uppercase E. Okay, so this is an important thing to remember. So when it comes to the bracket notation, how will you access the second level element? And it is very simple. As you can see in line number 85, the first is a root element which I am accessing through the keyword employee, followed by your child element. Okay, so this is how I can use the bracket notation and access all the element within the employee JSON. So this is the name of the employee. So this looks good. Now I can use the double colon for typecasting the result into varchar and also use the alias, very similar to what we have used for our colon notation. Let me run this SQL statement where I'm using the data type cast and alias. So now I do not have a double quote because I have explicitly casted it into a varchar. Let's extract all the element and you can pause and see how this query looks like. This has brought all the element the way we have used it into the colon and dot notation. Now, you may have a question. Can I mix the bracket notation, colon notation and dot notation together, and whether Snowflake will still be able to process it? Let's try that out. So if you look into this select statement and the line number 104, I am accessing the employee ID through the colon notation followed by dot notation. Good. I am accessing the name through the colon notation followed by colon notation, typecasting it into varchar and giving a alias name. Line number 106, I am accessing the root element through the colon operator and the designation, which is a second level child element, using bracket notation and typecasting it followed by alias. Line number 107, I am accessing the root element through the bracket notation, however, the sub element using the dot notation. Okay. And here, line number 108, I am accessing the root element as well as the child element through the bracket notation, and so on. So you can pause and think whether it will work or not. Let's execute this colon, bracket, and dot mixed notations and see what is the result. And surprisingly, it brought exactly the same result. If you are comfortable with colon notation, you can use colon notation throughout your JSON processing, or you can mix colon and dot together to make sure that child element is accessed through the dot notation, or you feel bracket notations are more expressive. As you can see in this example, you can also prefer the bracket notation. Okay. However, casting as well as alias remain same irrespective of what kind of notations or operator you are using to extract the element. Let me insert some additional record, run the JSON processing query, and look into the query profile. So I have total 3 rows available, and you can see I managed to get all the data correctly. If you look into this detail, wherever I have not typecasted, this screen is indicating that it is still a variant data type. We have covered the type of function in our chapter 1, and this is typecasted to a text. This is also not typecasted, that's why it is appearing as a variant. And this is a date of joining, which is typecasted to a date. And this is typecasted to a boolean, and this is also typecasted as a boolean. Let's view the query profile. I have only 2 steps. Step 1 is a table scan and step 2 is a result. If I go to the table scan, which is using a function called getPath, and we are going to see a JSON equivalent function in the later part of this video. Query profile does not tell you whether we have used colon notation, dot notation, or bracket notation to extract the JSON element. If you click on the result, here also you see the different expressions are used internally. When you come to the query detail, through the query detail, you can understand whether colon notation, dot notation, bracket notation, or a combined of all these 3 notations are used or not. Snowflake has a very nice feature to hold the result also. So if your role has a permission, you can also export the result without rerunning the complex JSON query. And you can click over here, you can give the name of the file, it will download the data into CSV format. And this does not need any running virtual warehouse or a compute. And let's try that. So I am in my warehouse, and right now their warehouse is started. I can go and I can say suspend the warehouse. It says suspend. Now my warehouse is suspended. I will go to the activity, and here when I say export result, and I say employee JSON, click on export, and it has downloaded the employee JSON data for me without any warehouse requirement. Okay, so this is one of the important feature in Snowflake which we generally do not know and end up spending compute for download our old executed queries also. Now let's try to work with a complex JSON. This is my new worksheet, and let me change my context quickly. So my context is changed. I'm going to create another table called employee underscore JSON underscore 02. It also has a field called JSON data of variant type. So my table employee underscore JSON underscore 02 created successfully. Now I am going to insert a record into this table using parse JSON function. And let's quickly analyze how this complex JSON looks like using our JSON visualizer. So this is a valid JSON having a root element called employees, which is nothing but collection of employee object, and they are wrapped in a bracket notation. So if you shrink it, you can see this bracket sign. It means it can hold multiple JSON object, and each employee object is having employee ID, name, and couple of other attributes. Followed by it has education as a collection of object where it contains 2 degrees. It also has a collection of string, and finally it has previous experience as a collection of object. When we try to see in a visual form, it looks like this. I have employee, and the immediate elements are ID, name, designation, and so on, which we have seen in our simple JSON. And it has a list of education. It is wrapping your degree, university, and year. It has a skill set, which is nothing but a collection of string. And finally, experience array, which captures the previous experience of the employee. Let's insert the employee JSON object and start querying it. So number of rows inserted is 1, looks good. So let's execute the select statement and see the result. So I managed to fetch the entire data. So in the previous example, when we selected the employee object, I get the entire object in the curly braces. However, when I do it for JSON2 table, it is a collection, and when I click on this result, I can see the bracket notation instead of curly braces. Okay, it means that I have to use the index to access the individual element within the employee root element, and for that, this is how my syntax looks like. Now I can see the individual employee element, and once I get the individual employee element, I can start fetching the individual element within the employee element. So I have to give employee 0th index followed by the element name. And let's run this SQL statement. So this is the employee ID. Double quote is coming because this is a variant data type. I have to use the casting and the alias. So here the result is casted into varchar, and then the alias name employee ID is given. When I click on that, it shows it is a text data type. So I have already written the query for you, and I am accessing all the 0th element with index 0. And when I have to access the education, let's see how the education looks like. If you see, education element is nothing but an array of object. This is my 0th element, and this is my first element. So I have to use education 0, education 1. I have to use education element followed by bracket notation, 0th element, first element, use the dot notation to access the individual elements. And that's what I'm doing it. This is my first degree detail, and this is my second degree detail. So this is how I access the individual element within the array. Next is my skill, which I'm not converting into a varchar or a text. I'm converting directly into an array. And for the previous experience, I am not converting into varchar, I am rather converting into an object. Okay, so this is how you can use different data type to convert as per your need. Let me run this query. So I got all the result, and if I click on this skills, you see this is an array data type, and if I click on this previous experience, this is an object data type. If I go to the query profile and show one important thing, when you click on this result and expand this list of expression, wherever I'm using the double colon notation, the Snowflake is internally using 2 object, 2 array, or 2 character kind of SQL function to convert them, to keep it consistent. So no matter whether you use 2 object, 2 array, or 2 character kind of a function, or you use double colon notation, in both the cases, internally Snowflake convert them into this expression to optimize it. Otherwise, query profile has nothing specific compared to our previous run. Now let's see how it looks with a bracket notation. As we have seen, you have to use single quote and you have to use the bracket notation. Rest looks exactly same. So if you are using the employee, it has to be used 0th element or first element. If I am using education, I have to use 0th element or a first element, and the typecasting has to work the way it is working with colon and dot notation. Let me execute this query. This also brought exactly the same result. And if I go and look into the query profile quickly. List of expressions are exactly same, so no difference. So this is how we can use the bracket and index to access individual element. If they are array or if they are object, we can continue to access through the dot notation to the last level of the JSON. Now let's understand the use of a SQL function called check.json in Snowflake. This is my new worksheet, and to demonstrate how this check.json function works, I am going to create a table called employee_JSON, which does not have a variant data type, but it has a column JSON as a string of varchar data type. So my table is created successfully. I am inserting this entire JSON object as a string, and for that I am not using parse_JSON function. I am just using insert into employee03 followed by values. So let me insert 3 record. So this is a valid JSON, so I will not have any problem. This is my second JSON, which is also a valid JSON. When I'm inserting my third JSON, comma is missing. Let's try that out in our editor. So my editor says this is invalid JSON, and it is clearly saying that it is expecting a comma, but the comma is missing. Since I'm inserting as a string, this insert will go without any issue. Now you will have a situation where your JSON data file is available as a varchar inside a table, and you would like to validate your JSON file before you extract element. So either you can use parse.json or you can use this function called check.json. But before that, let's execute the select statement and see how the data looks like. So I got ID1, ID2, ID3. And now I am using this check_JSON, and I am passing the column name, which is nothing but a JSON in form of a string. Let's run this SQL statement and see the result. If it is a valid JSON, this function returns a null value. If it is not a valid JSON, then it will tell the missing comma line 10 position 13. If I use the parse.json, what happens? The parse.json expect a valid JSON, and that's why JSON check function comes handy when your JSON data file is stored as a string in particular column in your table. So whenever you are processing a JSON file which is not a valid JSON, make sure you use this JSON check function before you process the data. Let's quickly see the query profile. So when I go to the result, it says it is using a check.json function. It does not translate to anything new. Okay, so your query profile looks pretty simple. And now you know when to use check.json function and when to use parse.json SQL function. We will understand how to use another interesting function called JSON extract path text SQL function. So this is my new worksheet. Let me quickly change my context. I am going to create a table called JSON_4, and there are two fields. The first field is ID, and the second field is JSON data of variant type. I am going to insert 6 record into this table, and the data looks like this. You have a root element called root A1, and it has a value A1 value, and I have a root B1 and it has a value B1 value. Another 2 record where the root value is exactly same. However, the root value is holding an object, and let's see how does it look like in our JSON editor. This is how it looks like. It has a root element root_A1 text, and it has another object called root A1 L2, which is a level 2, and value is A1 L2 value. Okay. Very similar for B1, and then root A1 and root B2, and it has another object, and this object has an array. Let's see this text in visualizer. So root A1 L2 level 2, it has 3 elements 0, 1, 2. Another record where it is root B1 L2, which is level 2. Again, it has a 3 element. Now let's quickly insert all the record and see how the result looks like. So all 6 records got inserted. Let's execute the select statement on this JSON4 table. So it starts with ID 1 and ends with 6. So I have a common root element root A1 on ID 1, 3 and 5. And I have a root B1 and root B1 on ID 2, 4, and 6. And if you look again, I have a repetitive root A1 L2, root A1 L2, and root B1 L2, and root B1 L2. Okay, so this is how the pattern looks like. Now let's try to understand what this JSON extract path text does. It takes your JSON data, which should be a valid JSON data, and it will try to find whether any element exists at the root level. If it finds this element, it returns the value of the element. If it does not find that element, then it returns a null value. Okay, so when I'm using this function, I am passing this JSON data and telling, do I have a root element named root A1? And let's run this, see what result does it bring. Let me put the ID and JSON data so it will be more clear. If I look into the result, it was looking for an element named root A1, and the value is written like A1 value. Here it has found root element. It has written my root A1, this is a value, and row number 5 is also having the root A1, and that's why it has returned the value for this one. This is how you can use JSON extract path text. Now if I run the same command for B1, now let's see what happens. This time all the root A1 is returning null because it is looking for root underscore B1. Okay, so all the root underscore B1 value has appeared as a result for this function. If I have to go to the level 2, then I have to say I am looking for all the root element named root underscore A1 followed by all the child element which is named as a root underscore A1 L2. Let's run this once again. Now let's try to find whether element root A1 exists at a root level followed by root A1 L2 element exists within the root A1 or not. And let's run this query. So all other values are null because root A1 and root A1 followed by root A1 L2, root A1 L2 only available in ID 3 and ID 5, and that's why I got this 2 result. Now the later part of the video will show you how to use this function and extract the data from the JSON which is having a dynamic values. This part of the video, we will see how to use JSON extract path text function for some of the JSON where structure is bit dynamic in nature and there are some degree of complexity to process the data. Let me switch my context. Now I am going to create a table called employee underscore JSON underscore 05. It has employee ID as a number and JSON data as a variant column. Now I am inserting 5 records in this table and this is how the each JSON looks like. Let me go back to my JSON visualizer. This is my first JSON where employee ID is 1. And this is how this employee detail looks like. If you see in the contact details, it has total 3 elements and they are in order because it is an array and it is saying the type of contact detail is a fax followed by phone and followed by mobile. When I go to the employee 2 start with mobile, then fax and then phone. Employee 3 does not have phone and fax and it has only mobile as a contact detail. If I go to employee 4, it has just a fax detail, but it does not have mobile and phone. And for my 5th employee, it has only phone, but it is missing fax and mobile. If you look into the contact details, they are ordered list. So now let me insert these 5 records quickly. This is my first record, second record, third record, fourth record, and this is my 5th record. Let's validate how do they look like. So if you look into the contact detail, this is how they appear as a result. I can use the colon and dot notation to access different element. And here for contact details, I am using the index 0, 1 and 2 and assuming that the first will always be phone, second will always be mobile and third will always be fax. Let's see what happens. So I managed to fetch the detail, looks good. But if I look into the second employee, my phone is 123, mobile is 456, and fax is 789. Let me go back to my editor. My mobile is 123, fax is 456, and phone is 789, which is completely wrong here, right? So now the question is that how can I really fix it? So to fix that problem, I have to use a case statement. Along with that, I'm going to use JSON extract path text function where I'm passing the JSON data and checking whether the type value is phone for the first element. If yes, assign the value. If the contact detail index 1 is a phone, then assign that phone value to the phone column, and if the second index is type phone, then assign the second value to the phone. And by doing this JSON extract path text and using the case statement, I would be able to assign a right value to the right column. So this is how my actual SQL looks like. Here you see I am fetching the 0th index, first index, and second index. For each of them, I am checking whether it is phone type or not. If the type is phone, then assign this value to the phone column. Likewise, I am doing it for a mobile and followed by fax. Okay, so this makes the query little longer and lengthy. However, I have no other way to extract the dynamic value from the JSON. Now let me run this SQL statement. Now if you look for employee 2, I got 789 is my phone. Let me check. Employee 2, 789 is a phone, 123 is mobile, and 456 is a fax. So using this JSON extract path text along with your colon notation and dot notation and index value, you would be able to extract all the element from your JSON data. Now let's go and check how the query profile looks. Does it look little different or it looks exactly same? My query profile does not look very different. Let me click on the result. So when you hover that, you would see it is using a complex expression to extract the necessary detail. And this is how it works internally in the Snowflake. So now we know when to use parse JSON, when to use check JSON, and when to use JSON extract path text function, and use this function to query and process the JSON data file. Now we'll quickly talk about some of the limitations and feature of these three JSON functions. So when we talk about a parse JSON function, it cannot take more than 8 MB of data. So if you have 10 MB of string, or if you have a larger data set which is available in a JSON format file, then parse JSON may not be the right function to use it to validate whether it is a JSON data or not. So the parse JSON preserve exactness by treating your decimal in appropriate data type. When you use parse JSON, and we have also seen that it generates an unordered set of key value pairs. So do not assume the way your JSON text appears, it will appear as a result of parse JSON. If you give null input to parse JSON, it generates a null value. However, if the null is in a single quote, it generates a null string, and which is not equivalent SQL null object. Parse JSON also return null if it is empty string or string with white spaces. So remember this point. I have really not tried check JSON and JSON extract path text for a large data size. In this demo, we have used only a small set of JSON data file, and that's why everything worked without any issue. However, if you try to use this function for a very large JSON dataset, which is more than 8 MB or a 16 MB, do let me know in the comment section whether you end up with any error or it works without any issue. So these are the couple of limitations, and by using these functions, you can really query complex and dynamic JSON. This chapter has covered the different type of JSON file, their classification, and how to use Snowflake provided built-in SQL functions, parse JSON, check JSON, and JSON extract path text to extract the element from your JSON structure, whether it is a complex JSON, sparse JSON, or inconsistent JSON. Now, you must be curious how to use the flatten function to extract the JSON element, and do we still need these functions to fetch and extract the values from the JSON structure? We are going to cover the flatten function in the next chapter. So continue to watch this space and also explore my other video and other playlist which covers wide variety of topic. So thank you for watching. Keep learning and keep growing.